So now talk about questions number 4. Shows that d dx cotangent x is equals to minus cosecant x. So they ask you to derive equation, which I like it very much. So this is only 2 marks here. So how do we need to do that? So this cotangent x, we know that it is cosine x over sine x, correct? So what are the things you can use? You can use quotient rules. So this is d dx cosine x over sine x is equals to sine square x, and you differentiate the top, become minus sine x, retain the bottom sine x here, and then minus, retain the top, and differentiate the bottom, become cosine x. Okay, so ultimately you get minus sine x squared minus cosine x squared divided by sine x squared at the bottom. So this become a identity. Sine x squared plus cosine x squared is 1, correct? Okay, you need to recap your O-level A math. So this is minus 1 divided by sine x squared. So this become minus cosecant x square x. So it is QED, or you can use shown. It's only 2 marks, by the way. So second questions, you ask questions. If these are the differentiation, we integrate this thing, isn't that given us somewhere similar to cotangent x? What you learn in your O-level additional maths. To show that sine 2x tangent x is equals to 2 sine square x. Only 1 marks here. So I think you need to recap your O-level A math. Left hand side is sine 2x. So this is 2 sine x cosine x. Okay? So the left hand side here, tangent become sine x over cosine x. So what you need to do, cancel it off. So this become 2 sine square x, which is equals to RHX. It's QED also. Alright? So the next questions, on the previous page, that we have proven sine 2x tangent x equals to 2 sine square x. So now what should we do? As your first, you ask you to find out the integration, definite integrations, pi over 9 from pi over 18 of secant 6x cotangent 3x dx. So how are we going to resolve this complicated problem? No worry, you have cosecant. This is 4 marks here. Anyway, it's very worth to explore. But you look at cosecant here, you know that this is 1 over sine x squared. Am I right? And cotangent here, in fact, it is 1 over tangent 3x. So you need to recap yourself for trigonometry. And we also know that from the previous page, write it down. This is 6x, this is 3x. So that means that the theta is 3x. So we know this identity. Sine to theta tangent theta equals to 2 sine squared theta. And the inverse of it is 1 over 2 cosecant theta, correct? So now, if let's say it's cosecant theta, isn't that the same, correct? So very simple, sub theta equals to 3x here. So the original stage become pi 18th, 1 over 18th to pi 9, 1 over pi over 9 become half, okay, cosecant 3x dx. The tricky part is that we have a 3 here. How do we address the 3? Very simple, substitutions. Let 3x equals to u, du equals to 3 dx, right? So these become x, and 1 pi over 9 of x become pi over 3 for this. And this pi over 18 become pi over 6 for this. So this 3x here, so the original form become upper bound with pi over 3, lower bound pi over 6, and this is 1 over 3, 1 over half cosecant u du. So this cosecant u du will give you cotangent u from 3 over pi over 3 to pi over 6, and with a minus here. Okay, so this is minus 1 over 6. Cotangent u, you know, when you remember your trigonometry, this is 60 degree, this is 30 degree. So 60 degree for cotangents is actually smaller. 30 degree is bigger, correct? So this is 1 over 6 square root 3, and this is become 1 minus 3, 2, and this is 3, and this is 2, so you can cancel it out, and there's a minus here, so become square root 3 over 9. Okay, so I just want to remind you guys how to remember the special angle. 60 degree, each one the length is 2, let's say that is 2, this one 1. Okay, so this 60 degree, you know Pythagorean theorem, this square root 3. Okay, cosine, tangent, you just remember as it is. If let's say that it is 45 degree, 1 square root 2. Alright, very simple. Thank you.